Hello explorers and welcome to another video. Today is the 14th of Advent of Code. And today we are going to solve the problem of doing fuel of ore, because we are running low on fuel and we are in an ore rich environment. The interesting part here is that the ore is actually something that you can't put directly to fuel. You need to go through a few steps in order to get fuel. So for instance, in this case, you can create A's and B's from ore, and then you have something here where you can take A and B's and create C's, and then you can take A and C's and create D's, and then you can take A and D's and create E's, and then you can create fuel from that. So we need to figure out a model that can actually handle this notation and can bring us from ore to fuel and figure out how much ore can we I think the puzzle down here was how much ore is required for one fuel, and that's what we're going to figure out for our puzzle input here. And I think this is pretty easily explained. It's pretty challenging to actually do. I haven't really figured something out for this yet. I guess that I will go backwards. I will take one fuel and then try to figure out all the branching paths and see which path leads me down to the least amount of fuel. But I need some data model to keep all of this in check here, and that could be challenging, because maybe you get to some places where you really get stuck and so on. So I will look into this one, and I'll be back when I have a solution. And I'm back, and it's been at least 2 hours, and I think I've figured something out here, so I will run it with the last example here and see if we get the right amount. Let's put it in. Yes, you get a gold star, I get a gold star, everybody gets a gold star. So we actually solved it with this functionality here. It's a little bit much, so I hope you are ready to follow along here. Let's see if I can just remove these panels here so we get more space. So first off, I have my material definition. So we know here that we have a lot of different materials that will produce other materials. But I looked on the right hand side here and saw that all materials that were defined to be something that you could create two only appeared once. So you knew that if I should create this one, I need some other materials. So therefore I could create a material, give it a name, give it an amount. So this is the amount of the requirement for this material. And then I put a list of requirements for this material that I have here in order to see for this amount I need these amounts. So that was the simple data structure that I had, and I had a little function here to update this. And I also needed a function to figure out if this material, a specific name of a material, is required in this specific material. So is this material required to produce this material? Because if I find that one material is required to be produced by another material, then I can't really resolve that yet. I need to resolve everything else in order to, so I have this standalone material that this is not required by anything else. So I just check, is this the name I'm looking for, this name? If it is, well, it's required for whatever this is, so I return true. Else I go through all the requirements. If it's or, everything requires or in the end, so I just continue on that one. And then I do a lookup for required for this child. So I have a lookup table here that I can take a string and look up the material definition for that. So I will look up for each definition here and check if they are required. And if any of them are required in a recursive loop, then I will return true. Otherwise, I will return false. And I also need a little function to update a map. And I think we will go back to this later because I think we need to look at the other functionality of this puzzle first. So first off, I have my input here. I read it in from a file. This is not much. I have a map here with all the materials. I read each line. I split them up with strings, and then I take the requirements and the definition. I first extract the definition and then go through each of the requirements, and I will extract the definition for these and add that requirements to the data structure. And then I will add the last definition to my requirements and give it a name here, so I will get it into that. If we look at this function extract diff, it just takes splits on space with the trim before it, and then it will take the second amount, which is the actual name of the material, and put into the material def, and then it will parse the integer before in order to see how many. So that's how we are extracting those. So when we have done the extraction and actually read the file, parsed the file, and figured out how this this should look, I needed a list of things that I need to work with. So I created a work list here. It's a string, and then how many I need of that string, and I put a long in there. And to my work list I put in 1 fuel, because that's what I need at the moment. I need 1 fuel. And then we start off here, and we will do this work until either the work list size is not as long as the work list size is not equal to 1 or the work list size is not equal to OR. This will pretty much say that if the work list size is 1 and it's OR, I need to stop. Otherwise, just run. So I will take the first OR here in my work list. And while it has more, I will continue here. And I will take the next one. So this is the next I need to look at. If it is OR, skip it. Then I don't want to look at that specific point in the list. I will see if I can find this one. So for each of the definitions in the work list, if it's either next or, I don't want to look at it at all. Because comparing next with next, or if next requires next, is not a good check. And then I will go through and look if the requirements, that definition requires this material, and if it's found, I will set that to true. And when I've gone through this list here, I can actually, I can put a break here to make it faster perhaps, but it was quite fast, so I don't feel that that is an issue. But if I find one, then I don't need to look anymore. And if found, then I will update the map here. If not found, I will update the map, because then I know that this is a material that is not required of any other material. So this is good to extract and see what is required for this one. And then I will remove that from the list and break out, so I can go a new line here. And when I only have OR left, I will print that out. So here is my update map. I give it a work list, then I will look for this. So this is the definition name. I will look for the definition name in the work list and get the value for that. So that is how many of this specific material I need in my work list. So that's the first value here. Then I need to take that value, divide that with the amount that this work specification specifies that is required, because then I will actually get how many of this specification I need to use. So this is my new value, and then I will go through all the requirements for this specification, and I will check if the current work list has a definition already, or a work specification for this specific name. And if it doesn't have that, I will create a new one with just 0. So I don't need any of this material yet, because I haven't done any calculation. So this is just to see that I can add to my work list and see that I have values in it. And then I will just get this specific definition name, that's the old value, and I will add the old value, and then just take the amount times the value of what is required now. So how much do I need of this specific material? So this will update my work list with requirements. And this should boil down to actually just having OR left, and it does. So I get the value, and that was the value we put in. So now we need to look at what part 2 entails, and I will get back to you when I know. And I'm back, and now I got this value here. You have 1 trillion amount of ore, and you need to figure out how much fuel you can produce from 1 trillion. And they have some examples here, and then I want to know the actual result for our value. And I'm not really sure, but I believe it's just a straight divided by, because we have found the most efficient way to create fuel, I believe. But I guess that we will see here. Let's just print out the values here. So we'll take that one and take that one and put in ore here. and put in that one, and put in that one. Let's see what values we get. Let's see here. No, we get more. I need to think about this a bit and see what I can come up with. I'll be right back. And I'm back after a long time of trying stuff out. I tried to simplify each step. So I went through all the requirements and looked for the requirements that only had OR. So I had this function that went through and checked that all the actual values were ORs. Then I had one that went through and added up all the OR amounts. And then I have this simplify function here that went through all requirements. And if they were not OR, or were not the specific definition that I put in to simplify with, then I would just add them to the new requirements. Otherwise, I will get the OR amount of this definition and then multiply that OR amount with the amount required for this definition divided by the amount for the definition with the OR amount. And then I get a new amount that I could put in here as an OR requirement, and I put the ceiling of that into the new definition. And then I replace the requirements here. And if I simplify all this, I just get one requirement left called fuel, and the OR amount out of that is 1278. But 1278 divided by a trillion is not the right value. It's close, but it's not the right value. So I'm not really sure how to solve the second part here. The second part is always more tricky, and I believe now that we are in day 14, we get the sum of the really tricky ones. Whoa, 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 whoa. Stop, Daniel. This is me from Saturday morning. I actually, before I published this, I went in, took a shower, and went to bed. And during the shower, I actually figured out that, wait a minute, you can do this even more pragmatic than I was doing it. You can just do a while loop and run over it until you get to 1 trillion. And when you get over 1 trillion, you just break. So I changed my little code here to run through all the OR amounts until I went over 1 trillion. And here I have my OR amount, that which I check, and I set it down here. And then I just go fuel amount 0 and then add the fuel amount for each iteration and try every fuel amount I can and then print it out down here. So that's the most pragmatic solution. I let it run overnight and I got this number here. And this is 4,052,921. But I will try 20 because this fuel amount has gone over 1 trillion. So it's 1 too much. So let's try with the value that is 1 less than the value that we actually got and see if that's the right answer. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. As we solved day 14 as well. I hope that you found this video interesting and perhaps a little bit amusing. And I hope that you learned something from this. If you have any comments and suggestions, leave them in the comment section down below. If you like this video, give it a like, share it with your friends and colleagues. If you like tutorials and interesting new libraries and other programming stuff, mostly in Java, then join this channel and subscribe. And I really hope to see you in the next video.